So now we'll do question 7.51. I think I missed this particular question while doing the EOT. So let's try to do this. A 0.28 kilo ball has an elastic head-on collision with a second ball that is initially at rest. So we have a particular ball, a 0.28 kilo. So I know the mass, 0.28 has an elastic head-on collision with a second ball that is initially at rest. So there is another ball which is initially at rest. So I know the velocity, which is 0. But I don't know the mass. They have not told the mass. So I will mark it as, let's say, m2, and this is m1. And the second ball moves off with half the original speed of the first ball. So I don't know the speed of the first ball, but let's say it is v. And they are saying the second ball moves off with half the original speed of the first ball. So there is collision. And after the collision, what happens? The second ball moves off with half the original speed of the first ball. So I can say the speed will be v by 2. Because here it is v, so it will be v by 2. Here it is 10 meter per second. So it is half of 10, that is 5. So 0.5 v or v by 2. What is the mass of the second ball? Okay, we need to find m2. That's the first part. We know the mass of the first ball. We know this, 0.28. But we don't know what is the velocity with which it left. So we need to find v1f also. Yani what is the velocity after. So we have to find the mass of the second ball and we need to find the velocity of the first ball. So let's try to do it. The first, it's an elastic collision. So what we will do, we will try to do the momentum conservation. So whenever there is elastic collision, we do momentum conservation and then we do kinetic energy conservation. Okay, I'll try to get some more space here. Okay, so what we are going to do is basically try to solve this. It's an elastic collision, so we can do two things. One is momentum conservation, another is kinetic energy conservation. So first do the momentum conservation. P is momentum, so I'm doing the momentum conservation. Initial momentum should be equal to the final momentum. Initial momentum for the first ball should be equal to m1v, that means 0.28 times v, plus m2v, that is the mass of this ball, we don't know, times velocity, which is 0, so effectively 0, equal final velocity. We don't know about the first ball, but we know the mass, so it will be 0.828 times vf, plus the second one, which is, I don't know the mass, m2 times v by 2, because it is half the original speed. That is the part. So I don't know here what is the initial velocity of the first ball. I don't know what is the final velocity of the first ball, and I know that the initial velocity of the final velocity of the second ball is half the value of the first ball. So, and I don't know the mass of the second ball also. So that is 3 unknowns. Anyway, so this is 0.28v. What I'll do is I will try to simplify this equation. I will bring these together. Like I will try to bring this part together, and it will become 0.28 v minus vf equal m2 v by 2. Okay. Let's keep it that way. Now we can also do kinetic energy conservation. So I'm dividing it into two parts. Kinetic energy conservation. Let's try to do that, because here we have 3 unknowns, so that's why we don't know that how the equations are going to turn out. So for kinetic energy conservation, half mv squared. So that means half times mass, which is 0.28, times v square plus 0 equal half 0.28 times vf square plus half m2, we don't know the mass, and v by 2 square. There is half here, half here, half here, so half will get cancelled throughout. and I'm left with 0.28 v square and 0.28 vf square. So I'll bring it this side and it will become 0.28 v square minus vf square equal m2 v square over 4, because this is m2 v square and 2 square is 4, so m2 v square over 4. Now I can change this relation. I can write it like 0.28 v square minus vf square. I can write it v minus vf times v plus vf, because a square minus b square, it's a mathematical identity, is a minus b times a plus b. So this will be like that and equal to m2 v square over 4. Now what I do is, I will, here we have v minus vf, here also we have v minus vf, this entire 0.28 v minus vf, and here also is v plus vf m2 v square by 4. I try that what I'll do is 0.28 v minus vf, I will place it here instead of this. So this will become m2 v by 2. So instead of this part, here, what we are doing is that we are placing this part there. 0.28 v minus vf should be equal to m2 v by 2. So if I do that, this becomes m2 v by 2 times v plus vf equal m2 v square over 4. Now m2 is here, m2 is here, v is here, v is here. So m2 v square can be written as v times v. So I'll cancel one v, and this is 2, this is 2. So this equation becomes v plus vf equal v by 2. v plus vf equal v by 2. And from here vf comes out to be v by 2 minus v, which is equal to v by 2. That means the velocity of the second ball is equal to v by 2. That is half. The second ball also reduces to half. That is the final velocity of the first ball. Final velocity of the first ball becomes v by 2. So imagine like first ball was traveling with v, and now it imparted half the velocity to the second ball and half the velocity remained with this one. Now we need to find the mass as well. So if we need to find out the mass, Vf is equals to v by 2. So I can place this back in any of the equations. So I'll place it back here. Vf is equals to v by 2. So I can write it 0.28 times v minus Vf is v by 2. So v by 2 equal m2 v by 2. So this becomes v minus v by 2 is v by 2. So 0.28 v by 2 is equal to m2 v by 2. This is v, 2, 2. M2 comes out to be 0.28 kilos. kgs. So the mass of the second ball becomes 0.28 kilos, which is kind of strange. 0.28 kgs. That means it is exactly the same. Okay. I'm doing some mistake here. Plus Vf, Vf is equals to v by 2 minus v. Okay, yeah, there is a mistake. V by 2 minus v will become minus v by 2, not v by 2. So it is negative v by 2. Negative v by 2, that means the first ball starts moving in the opposite direction with the velocity v by 2. The first ball starts moving in the opposite direction with v by 2, with the speed v by 2. And if that is the scenario, I can place Vf is equals to minus v by 2. So it's become v minus v by 2. That means plus. Because Vf is v minus v by 2. So minus will become plus. And this will make it 3 v by 2. Okay. Change it. Let's correct it. So I'll place Vf is equals to minus v by 2. It will become 0.28 v minus v by 2 is equals to m2 v by 2. v minus v by 2 will become 3v by 2 times 0.28 is equals to m2 v by 2. Here it is v by 2, here also it is v by 2, so cancels. I'm left with m2 comes out to be 0.28 times 3, which is 0.84 kilos. That is the mass of the second ball. That is the mass of the second ball, 0.84. Okay. The next part of the question says, what fraction of the original kinetic energy is transferred to the second ball? So what fraction of the original kinetic energy is transferred to the second ball? That is what we need to find out. So we can find out the original kinetic energy, we can find out the kinetic energy of the second ball, and then we can find the difference. So the question says what fraction, we need to find out what fraction of the kinetic energy. So we can find out the initial kinetic energy of the ball, because now we know the speed as well. Do we know the speed? Okay, let's keep it as v, no problem. So we can find out the initial kinetic energy. Kinetic energy initial will become half times 0.28 times v square. The final kinetic energy of this particular ball, the second ball, it will be half. And you know, this mass is basically 3 times. So half 0.84 times v by 2 square. So this becomes half times 0.84 times v square by 4. If this is the final kinetic energy and this is the initial kinetic energy, so I can find the difference. That means delta K will be K initial minus K final. That means how much change happened. We need to find out that. So, okay, you might say that why we are not doing final minus initial, because here we just need the change. Some energy has been lost. So we just need the initial and final, that how much is the difference, because we need to find out the ratio. And K minus Kf will become half, will get common, half times 0.28 times v square minus half times 0.84 times v square by 4. Take things common, it will be easier. Half 0.28 will get common, v square will also get common. I am left with 1 minus 3 by 4, which is 0.25. Okay, you might say that how did I get 3 by 4 and everything? What I did is 0.84 is 3 times 0.28. So I wrote 3 times 0.28. I took 0.28 out. I am left with 3 by 4. 1 minus 3 by 4 is half times 0.28 times v square, and this is 1 by 4. This is delta K, change in kinetic energy. And if I know the delta K, that is the change in kinetic energy, they are asking what is the ratio that has been transferred. So they are asking delta K over K. I know delta K, that is half times 0.28 times v square times 1 by 4 over K is the initial kinetic energy, whatever it was. So half times 0.28 times v square. This entire term will get cancelled and I am left with 1 by 4. So the ratio or the fraction of the energy which has been transferred to the second ball from the first ball is 1:4 or 1 by 4. This question might look complicated. It is a little bit complicated, to be honest. But if you do it by yourself, slowly, all you need to do is conserve the momentum and the kinetic energy. It's more of a maths question than a physics question, because there are like solutions which you need to solve two different equations in a manner that things get cancelled out.